What is the mathematical relation? What is the mathematical relation between the image distance, object distance, and radius of curvature of a convex surface enclosing a denser medium in case of refraction of light from denser to rarer medium at the concave spherical surface provided the object O point exists in the denser medium. This is a concave refracting surface. XPY is the concave refracting surface towards a rarer medium of refractive index mu1. XPY is the concave refracting surface. XPY is the concave refracting surface, and this refracting surface encloses a denser medium, and this refracting surface is concave towards the rarer medium of the refractive index mu1. This is the principal axis of the refracting concave surface. This is the principal axis of the refracting concave surface, and we can denote the center of curvature. C is the center of curvature of the refracting concave surface, and this refracting concave surface encloses a denser medium of refractive index mu2 from a rarer medium of refractive index mu1, from a rarer medium of a refractive index mu1. And this refracting surface XPY is concave towards the rarer medium of refractive index mu1. O is the object point lying in the denser medium on the principal axis. O is the object point which exists in the denser medium on the principal axis of the refracting concave surface, and we can draw the normal AC. We can draw a normal at the point of incidence A. AN is the normal, and a ray is traveling from O to A. A ray is incident at the point A at an angle of incidence I in the denser medium, and this is the actual direction of incident ray OA. We can extend the actual direction of incident ray along this direction, and the refracted ray the ray will be refracted along this direction. The ray will be refracted along the direction AQ. This is AQ is the refracted ray which will be refracted into the rarer medium at the angle of refraction R, and this refracted ray AQ will appear to diverge from the point I. That's why I is the virtual image. I is a virtual image which is formed on the principal axis of the refracting concave surface, and it is also formed in the denser medium. In this case, OA is the incident ray. OA is the incident ray which is traveling from the object point and incident at the point A, and AQ is the refracted ray. The ray will be refracted into the rarer medium. It will be refracted away from the normal because it is refracted from the denser medium to rarer medium. Now we can denote the object distance. The distance of the object point O from the pole P is the object distance, U is the object distance, and V is the virtual image distance. V is the distance of virtual image point I from the pole P. We can denote the radius of curvature of the refracting concave surface. R is the radius of curvature of the refracting concave surface XPY. Let XPY be a refracting concave surface towards a rarer medium of refractive index mu1. XPY be a refracting concave surface enclosing a denser medium of absolute refractive index mu1, absolute refractive index mu2, and this refracting spherical surface XPY is concave towards the rarer medium, towards a rarer medium of refractive index refractive index mu1, rarer medium of refractive index mu1. It should be refractive, not refracting. The object point O, lies on the principal axis, of the concave refracting surface, xpy in the denser medium. That means the object point O lies in the denser medium. A ray of light from the object point O, is incident at the point A. A ray of light from the object point O is incident at the point A on the concave surface xpy, at an angle of incidence I, in the denser medium. Cn is the normal at the point of incidence. A. Cn is the normal at the point of incidence A. Now the ray will be refracted along AQ. The ray incident at the point A, will bend away from the normal in the rarer medium, after the refraction of light through the concave surface. The ray incident at A will bend away from the normal Cn after the refraction through the concave surface xpy, and it will be refracted. Along AQ. Into the rarer medium. It will be refracted along the into the refracted medium, and also you can denote another refracted ray that will be traveling along the principal axis. The two refracted rays AQ and OC will appear to diverge from the point I existing on the principal axis, on the principal axis of the refracting concave surface. The two refracted rays AQ and OC will appear to diverge from the point I lying on the principal axis OPC in the denser medium of refractive index. Hence, a virtual image under bracket I is formed in the denser medium. Virtual image I is formed in the denser medium and on the principal axis of the concave surface xpy. Virtual image I is formed in the denser medium of refractive index mu2. As the object point O exists in the denser medium, of refractive index mu2, as the object point O exists in the denser medium of refractive index mu2, that's why the denser medium should be the first medium. As the object point O exists in the denser medium, that's why the denser medium is known as the first medium. The denser medium of refractive index mu2 is the first medium, and the rarer medium of absolute refractive index mu1, is the second medium. In this case, the object point O exists in the denser medium. That's why the denser medium is the first medium, and the other medium the rarer medium in which the ray is refracted along AQ is the second medium. In this case, rarer medium is the second medium. Rarer medium of refractive index mu1 is the second medium. Now we can write down the relation between the image distance, object distance, and radius of curvature. Now we know that refractive index of second medium, that is mu1, divided by image distance, that is vu, minus the refractive index of first medium, that is mu2, divided by object distance u, which is equal to refractive index of second medium, which is mu1, minus the refractive index of the first medium, which is mu2, whole divided by radius of curvature r. Therefore mu1 by v minus mu2 by u will be equal to mu1 minus mu2 whole divided by r. Mu1 by v minus mu2 by u is equal to mu1 minus mu2 whole divided by r, which is the relation between the image distance v, object distance u, and the radius of curvature, under bracket r, and the radius of curvature. Mu1 by v minus mu2 by u is equal to mu1 minus mu2 whole divided by r. That is the relation between the image distance v, object distance u, and the radius of curvature r of the refracting concave surface. Radius of curvature under bracket r of the refracting concave surface in case of refraction of light, through the spherical concave surface from the denser medium to rarer medium, through the concave refracting surface xpy from the denser medium to rarer medium. From the denser medium to rarer medium.